Good morning, it's Heath Williamson here, Team Acceleware, and I'm on my way to the AER Core Research Center. It's November 12, 2020, and I'm meeting with Broadview Energy's Ian Temple. And what we're doing today is we are going to be looking at some core that was taken from the Marwayne asset, a well location that is just north of where Acceleware will be conducting our RFXL commercial heating test. The exact location for this well is LSD2, section 18, township 53, range 1, west 4. This core, I believe, was taken back in the 90s by blast from the past here, Pan-Canadian, if anybody remembers Pan-Canadian. So with the core, we are going to be selecting some sample points and taking some plugs for the purposes of doing some particle size distribution analysis, some thin section work, and potentially some XRD work. And with that, with those results of those lab analyses, we will be selecting the appropriate sand control and the appropriate gap size for our sand control. And the goal here is to prevent sand from coming in to the well and wrecking our pumps and blowing holes through our sand control, but allowing some of the finer mineralogy to come through. We don't want that finer mineralogy to pack up on the outside of the sand control and plug up our well either. So that's the balance we're looking for. We're going to get started on the work, going to mask up and going to get going. So hope everyone's well, and please stay tuned. More to come.
This core encompasses the entire sequence of the GP channel. We start at the capping sequence and go down the core to the erosional contact at the bottom of the channel. The cap rock is composed of finely laminated mudstones and shales that were deposited in a deeper water setting. There are 2 meters of this very tight material acting as a seal to the GP channel. Note the lack of oil staining. The GP reservoir in this core is a channel sand incised through regional lagoonal muds, coals, and silts. Within the channel is an assemblage of high energy facies, as observed in this core. The entire channel in this core is oil stained and is regionally within the oil column of the Marwayne oil pool. At this location, the first 2 or 3 meters have a significant number of silt and mudstone laminae within the sands. This is typical near the final phase of deposition of a channel as it wanes and is eventually abandoned. As we move further down into the section, the mud layers become less frequent. Here in the heart of the deposit is a medium to fine-grained, well-rounded quartz-rich sandstone. The bedding angles are high and its dip direction changes frequently, typical of channel deposition. Core analysis shows the sand being 33 to 36% porosity, 2 to 4 darcies. Right in the middle of the pay column is a calcite streak. This is the cleanest part of the channel as measured on the gamma ray log. Calcite is a very common occurrence in the Manville and is often seen in pools throughout Alberta. Calcite deposition is quite random, and there is only one well nearby that has calcite in it. This portion of the channel shows 2 occurrences of mud deposits. The first occurrence is a depositional mud layer that can form a baffle in the reservoir. Channel deposits are generally so heterogeneous, however, that these mud layers do not correlate any great distance. Just below these mud layers are a different kind of mud clast floating in sand matrix. Note the large white clast that is well rounded, which indicates it has been transported along with sand grains until finally deposited here. These mud clasts should not hinder reservoir performance. The high quality reservoir sands continue all the way to the base of the channel, with oil stains and oil saturation still very high.